All right, today we're going to cover section 5.6, day 2. We go a little more in depth with the quadratic formula. Recall that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, part of this formula is what's called the discriminant. Okay, the discriminant is b squared minus 4ac. This is inside the radical. Okay, and that part inside the radical actually tells us quite a bit about our equation and the solutions of it. So this part right here is the part we're going to focus on today. This determines how many and what kind of solution we will have. So if the value of the discriminant is positive, okay, if it's positive, that means b squared minus 4ac is greater than 0. If that happens, we will get two real solutions. Okay, it could be nice and easy like 6 and negative 4, or it could be something like 4 plus or minus the square root of 7. Okay, the plus or minus means two solutions. If b squared minus 4ac is less than 0, then it's negative. So if the discriminant is negative, we will get two imaginary solutions. Okay, two imaginary solutions. Okay, this is when we have like 1 plus or minus I square root 2, when there's an I in the answer. And lastly, if it equals 0, so if b squared minus 4ac is equal to 0, then we get one real solution. Okay, this one we only have one answer. So, example 1 and 2 say, find the discriminant and give the number and types of solutions. So for the discriminant, we need to know what A, B, and C are. So first find A, find B, and find C. So A is 1, B is 4, and C is 29. So if we use our formula, which is b squared minus 4ac, that's the discriminant, we would take 4 squared minus 4 times 1 times 29. So 4 squared minus 4 times 1 times 29 will give us negative 100. If you type it in your calculator, you would get negative 100. So our discriminant is negative. That means we would have two imaginary solutions. Because it's negative. So finding the discriminant tells you how many and what type of solution. In the second one, notice over here our equal sign in the middle. We have things on both sides of the equation, so we have to make this equal 0. So what I'm going to do is cancel out things on the left. So I'm going to add 2u squared and subtract 5 from both sides. So it cancels. So 0 equals 5u squared minus 10u minus 5. So we got to make it equal to 0 first, and then we can find A, B, and C. So A is 5, B is negative 10, and C is negative 5. Once we have A, B, and C, we use the discriminant formula, b squared minus 4ac. So we get negative 10 squared minus 4 times 5 times negative 5. So negative 10 squared is 100. So we get 100 minus negative 100. When you do this, minus a negative becomes plus a positive. So really the discriminant equals 200. So we would have 2 real solutions. So it's positive. Positive means 2 real solutions. Negative is 2 imaginary solutions. And 0 would be 1 real solution. Okay. And we are going to cover one word problem. Okay, so this equation, or the 2 equations, are for when you throw or when you drop an object. Okay, think of like if you throw a ball or something up in the air to a friend across the room. So object being thrown would be here. Object being dropped would be the equation above that. So they tell us h is the height in feet, t is the time in motion, and this h0 means initial height, and that v0 is the initial vertical velocity. So if the initial vertical velocity is positive, that means it is thrown upward. Like a ball being thrown across the room up in the air to a friend. If it is negative, that means it's thrown downward. Kind of like if you're looking out a window and you are throwing something out of your window down at the ground. And if it is 0, that means object is dropped. So it's like you open a window and you just drop an object from a window. Instead of throwing it down, you drop it. Okay? All right, and this problem is a little bit challenging, especially because you got to draw a picture for it, but we'll work through it. So the water in a fountain leaves a spout with a vertical velocity of 30 feet per second. Okay, so we have vertical velocity 30 feet per second. That's positive 30, so it means it goes up in the air. After going up in the air, it lands in a basin 6 feet below the spout. So it lands 6 feet below the spout it just came out of. If the spout is 10 feet above the ground, how long does it take for a single drop to travel from the spout to the basin? Okay, from the spout to the basin. So we draw this picture. So there's a spout. I'm going to try my best here. There's a spout. And then there's a basin below that spout. Okay, it looks like this. Let me fix that. Okay, and then, so think of it as this comes down to the ground. Okay, so here's your water fountain. Okay, and what's happening is water is shooting up and coming down. Okay, so picture that, and this is all water in the basin here. Okay, so now if we look at the heights, it says that, the initial velocity is a v with a 0. The initial velocity is 30 feet per second. They tell us that this, after going up in the air, it lands in a basin that is 6 feet below the spout. So from the spout to the basin is 6 feet. If the spout is 10 feet above the ground, so from the spout to the ground is 10 feet, okay, how long does it take a single drop to travel from the spout to the basin? Okay, I'm just going to put in here that it's 4 feet from the ground to the basin. Okay, so we're looking for how long does it take. So I'm going to put t as in time, and I'm going to put a question mark. Okay, and before I get too far, I have to ask, is this an equation where the water is being launched or dropped? And in this one, it's being launched up in the air, so we are going to use the equation h equals -16 t squared plus v0 times t plus h0. Okay, and we said we're trying to find t. The velocity is 30 feet per second. Okay. And what we are looking for is how long does it take to go from the spout. So we're going from right here down to the basin. So from the spout to the basin. So the initial height is how high above the ground. So from up here, slide over a little bit, up here where that green is, that is 10 feet above the ground. So the initial height is 10 feet. And where we want to end up, which is h is where we want to end up, we want to end up down here in the basin. And how high above the ground is the basin? 4 feet. So our equation would be 4 feet above ground equals -16 t squared plus 30t plus 10. Because 10 is the initial height, and we're starting up here. 4 feet above the ground is in the basin. That's where we want to end. So if we're solving this, we have to make this equal 0. So 0 equals -16 t squared plus 30t plus 6. So that's 6 there, 6 feet above the basin. That's where this comes from. It's 6 feet above the basin. So we will use quadratic formula. A equals -16, B equals 30, C equals 6. So we use quadratic formula, and we're trying to find t. T equals -b, so -30, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So quadratic formula, if we find out what's in the square root, inside the square root is 1,284. If you use your calculator, 30 squared is 900, and it's 900 minus -384, and you get 1,284. Divided by 2 times -16 is -32. Okay, so we end up with the -30 plus or minus the square root of 1,284. So actually, I'm going to break this apart. Got a little bit ahead of myself there. So we have this. So we have negative 30 plus the square root of 1,284 divided by negative 32, or negative 30 minus the square root of 1,284 divided by negative 32. So when you figure this out, type it in your calculator. How you type it in, you either have to put parentheses around the top, or you can do it like this. Type in negative 30 plus square root of 1,284, then hit equals, and then divide by negative 32. And you should get negative 0.182 for the first one. And the second one, again, you would type negative 30 minus square root of 1,284, hit equals, you get a decimal, and then divide by negative 32. And for this one, you should get 2.057. So we got two answers. Remember, we're trying to find time. So from the time it leaves the spout and comes back down the basin, would it be negative 0.182 or positive 2.057? Since we're talking about time, time cannot be negative. So our answer is 2.057 seconds. Okay, and in problems like this, we want an actual decimal. We want to know how much time exactly does it take, like on our watch, and it'd be 2.057 seconds. And that is where we'll end for today.